Good morning, everyone. Good afternoon, and welcome to today's webinar. As always, I just thank you guys for taking the time to join us today. And, let's quickly dive in and get things rolling here. So as you guys are aware, we're here to talk about the topic of are engineering changes causing harness documentation headaches? And so, yeah, as you can tell today, everything that we're going to be talking about is in regards to cable and harness design, all going from an intelligent schematic into also an intelligent 3D model. I'll put an introduction slide in here, but my name is Thomas Smith. I'm an industry process consultant here at SOLIDWORKS. And my main focus here is on our electrical tools. So, focusing everything from schematic all the way into the mechanical integration. Been with SOLIDWORKS for a little over 2 years and just love it. Also joining me, as mentioned, is my counterpart, JP Emmanuel. And JP, you want to take a moment and introduce yourself?
How you doing? I'm JP Emmanuel. I am Thomas's counterpart out on the East Coast, and just as he said, I cover mostly the electrical tools for SOLIDWORKS and Dassault systems.
Awesome. So yeah, we're both excited to be with you guys today. Don't hesitate to get those questions in there as they come up, and we'll do our best to get them addressed. All right, so I was already on the table of contents. You guys probably have had a moment to kind of look over what we're going to be going through today. But yeah, we're going to start with a quick overview, and we're going to jump into the 2D to 3D harness workflow. And then specifically, we're going to talk about creating interconnect documentation off of, our information driven from that intelligent schematic, pulled off of that intelligent 3D model to create high quality interconnect documentation. And as mentioned, we'll try to have a open Q&A section at the end. I got a lot of content to cover. So with that, let's dive in. As stated, we're going to start with a quick overview. I'm not going to spend a lot of time here, but as we dive into this, I want to point out that SolidWorks is our SolidWorks Electrical is just a piece of the overall Dassault System SolidWorks ecosystem. We also integrate extremely well with all these other disciplines. Today, we're going to focus primarily on this upper quadrant of electrical and 3D CAD. Obviously, we're going to be producing some 2D drawings in there as well. Really, as we get into this, everything you're going to see, and as we talk about driving intelligence into our schematics or managing change, a lot of that comes and is all facilitated by the key factor, and that is our shared library database-driven system. So SolidWorks Electrical is powered by SQL, and because of that SQL, it is managing all of our metadata for us, our library information, symbols, etc., all of our wires. So the data is managed in a centralized location that all users have access to. So it's an easy, accessible library, but it is also, the single source of truth where everything, comes into the library correctly and comes out. The library drives a lot of the data behind the scenes. It's going to tell things such as the symbols to use in any given circumstance, as well as feed any metadata information that might be associated with that said manufacturer's part. So we're going to kind of see, obviously interactions with this library throughout and this database throughout the presentation today. Both interactions, when we're in mechanical, will be, connected and integrated into this same library as we are within schematic. One other key point I wanted to point out as we dive into this and going over the overview, another unique thing about our application is how we facilitate a multi-user collaboration environment. So we allow for multiple engineers and users to be on the same project at the same time. So whether that is electrical and electrical working simultaneously on the same project, or what we're going to look at today is the integration of mechanical into the workflow. And again, so you'll point out, or you'll see throughout today's presentation again, how we can simultaneously be connected and working through this project, interacting with the same data. All right, so getting into the 2D, 3D harness design. SOLIDWORKS Electrical comes with a lot of powerful tool sets that give us the ability, to quickly get our designs out. And not just, rough drafts, but full, intelligent schematics. Whether we're going to drop that in a high-level system one-line drawing, or further define, intelligent multi-line schematics. And what's great as we get into this is how we deal with a hierarchical system with a lot of flexibility of how information is accessed and distributed throughout the system. And so, yes, we can create, our schematics representing connectors, cables, harnesses. But furthermore, being able to feed that into our mechanical environment to ultimately give us the ability to produce what we actually need, our deliverables, right? What we need to manufacture, produce, our equipment. And so that's what we'll look at today. As we're in this, we're talking about, the pain of managing change or, having to operate in a manual disconnected world. Well, as we go through this, just keep in the front of your mind how SOLIDWORKS Electrical through our library and database-driven system help, ensure access to the accurate, up-to-date, appropriate information. And then how that we're in a fully associative environment, meaning that all components that are related, any BOM elements, wire information, is all maintained by SQL, guys. We're taking that burden off of you and allowing the database to maintain any of the links and associativity, removing that burden and that extra work from you. So with that, guys, let's dive in and take a look. All right, so here, to set the stage, I want to start in mechanical. We're going to be working in both environments, but again, I want to give you guys a clear idea as we get into the schematic of what we'll be interacting with today. So you'll see we're inside of a chassis system here. I got a few boards and connectors, that are laid out here mechanical. So, my mechanical guy has a leg up. He's kind of created his mechanical layout, and, I can get some good visibility into that project. As you're going to see here, this mechanical environment is integrated into our electrical project, and we'll talk about that more as we go on. So jumping over here into schematics, I am already into a scheme page, and I got some some defined black boxes, essentially just some generic boxes that I've dropped in to represent certain locations. Black box is an extremely powerful tool. What I'm doing now is placing a dynamic connector based off of a manufacturer's part number. Our database is highly interactive. We got powerful filters that allow me to select the exact part number that I need when I need it. And again, this database is centralized and accessible to the team. All of the information required for this particular connector, as defined by the manufacturer's information in that library, is going to be distributed into this connector as soon as I get it placed here. You can see we use snap and O-snaps. They kind of interfered with me there for a second, but there I get connector X1 with the terminals as they were defined by the manufacturer part. I really like, the way that we can drive our connector definition, our pin value information based off of the manufacturer part. It allows us to, ensure that, again, we're getting the appropriate information distributed through that symbol. Notice, again, the automated tagging that is happening. Here's a cool thing. I have one symbol instead of having to, access multiple symbols within this command. I'm able to, just do varying changes with this guy to get a different orientation for that. And again, when I hit force association here, what I'm telling it to do is to match those terminals that are assigned to these connectors to be identical to the terminal definition found in the manufacturer's part. This is important when we're connecting to 3D and to ensure that, as we start defining connections, et cetera, that all the appropriate information is distributed correctly. So here again, I'm just going through the process. I've selected manufacturer's parts. This is a 12 pin, but I'm only going to represent 10 of them in this particular case. So, again, it's a flexible system that we have access to, dynamic symbols or all types of, centralized database-driven symbology to represent our various connectors. So I'm, quickly, you're seeing me, do this in real time. I need to make a slight adjustment to my black box. So again, just some real quick, pulls with some grips can make it real easy. This tool is very powerful. It understands if I had remaining connections for a connector, I could continue to place those. So again, a really flexible tool that all of what is happening here is driven by that database. And that's why I'm doing it in this manner. You're going to see I'm interacting with one command, but as I grab these varying manufacturers' parts, and based off of that metadata, it is all propagated correctly into my schematic. I am removing the human element as far as putting the pertinent and important data in here. So you'll notice as soon as I place this guy, notice how I get some further descriptions. Again, that was driven by the database. I'm not having to populate this stuff in. Once it's in the database, we know it's there and can easily extract that. This ensures us, again, that we're working with the latest and the greatest data. So one more time, just again, interacting with that database, selecting several different manufacturers' parts, and getting these guys put in, and then we're going to get some wires. But I think it's real great. Again, we get that visualization of the terminal assignments, auto tagging, the distribution of any terminal information as required. Again, you'll see me interacting with various libraries. These are all centralized so that my entire team has access to these. What's nice is also in a manufacturer-driven environment, we can have these manufacturer's parts number that you see me assigning to these connectors also driving that mechanical model, as you saw in my introduction. So as I'm placing this, I'm not only defining, manufacturer, metadata, connections, and terminals, but I'm also telling the software which mechanical model is associated with said part number. So real quickly, I've defined some connectors within, my overall top assembly. Now I just need to connect these guys up. Right here, just for purposes of an example, I'm going to select just a standard wire style. All right, there's nothing important to it right now. To help speed this process up, I am going to turn on some settings that allow me to pull, multiple instances of this same wire type in one command. And I'm quickly, just going to really just make some quick and generic connections between these two. Again, notice how, quickly I'm able to interact and get this data with defined intelligent connection points on my symbols. As soon as these wires connect, the software understands the connections, the to and from information, and the properties on these wires. So we got to keep that in mind, as what we're getting ready to do now is to define some cables. So the cables are going to be managed on the project level. So on the electrical project, I can come in my cable manager and see all of the cables assigned to my project. I also have the ability, and this is cool, to manage my cables in a specific cable library. So this is separate from my manufacturer's library. And this data, again, is fully accessible, for filtering capabilities to allow me to get to the information that I need to quickly. And so I can, by whatever filtering commands, access and locate, the specific, in this case, cable that I wanted, 3-conductor cable, etc. Select it. We'll see that reference. Now I have a W7, and underneath there, I have those individual cores. One thing I want to point out, guys, is the properties on these cables. We have a few settings that we can toggle here. For one, notice all the cable information that we can specify here, such as the diameter, the bend radius, linear mass, voltage drop data, etc. And just to keep in mind, guys, if you do, are going to do 3D routing, this section is important. Right here, we have a new feature to call it Separate 3D Route Assembly. If you want to route each cable as an individual subassembly, you can check that box. Also, here is where we turn on the ability to run calculations. So keep that in the front of your mind. A lot of metadata, again, is being captured by an intelligent database-driven application. We no longer, have to, collect pieces of information that are disjointed and manually go through repetitive tasks. So I'm not doing nothing more here than adding a couple more cables to the project. Again, just some varying based off of the particular use case, but I'm going to select that guy, bring him down. And so you can see we got W8, all of his conductors are listed below there. Again, varying properties. If I did want to route that guy separately as an individual subassembly, I can do so. One more cable for this instance, and then we're going to get to associating the cores. The whole purpose of starting here in the 2D environment is so to help, understand the passing of information. The schematics are step one. We need to ensure that our schematics are defined and connected appropriately. Therefore, we're pushing the appropriate data downstream to mechanical. And okay, so we got our 3 cables. Now let's come back out here to our schematic. To associate these cores, it doesn't get any easier than this guy. So I just did a selection window. I'm going to right click, and in this context menu, associate cores. I can expand this. Here's my available cables. You're going to see I got 3 available cores for W7. Simply click associate. It is going to, distribute that information correctly. Notice again, right there, the cable designations are found there with any descriptions for the cores. So I'm just going to go through this same process of further defining the connections within this cable. So as soon as those are made, it understands to and from, and it populates, a lot of that metadata into these wires and into these cores and cable. And we'll take a look at a little bit that just here in a second once I finish associating W9. We're a super powerful tool. We have the ability to represent cabling in a variety of manners. Here you see me representing the individual cores, but I could represent these connections with a single defined cable in circumstances. So let's go take a quick look at the cable manager or library. So again, here's a area where I can manage the overall library. I just want to come in here real quick to just again point out some important information regarding our cable properties. When we actually come into, this view did not look good. Let me pull that down a little bit. Try to pull this out. So before you saw me defining some of these general properties or an area where we could have access to those. On the actual cable, though, I want you guys to keep in mind the cores, carry a size information as well. So in each cable, even though you define the diameter, we can come in on those cable cores and put sizing information there as well. So you got, a few fields that will help drive the appropriate creation of any given cable. So again, we're just going to go and take a look at all those. You can, customize and build your own cable library as needed. But there I've created and defined some cables real quick. Let's talk about creating and defining a harness. So in this example, you're going to see that I have several defined connectors. All right, I'm going to tell you, I went through the same steps as I did previously. I put down these connectors based off of manufacturer's information, had them created, and connected them with a generic wire. And, so what I have to do now, again, is, well, real quick, I'm going to number these wires. But I need to also tell the software that all of these components participate in a harness. But before doing so, as I mentioned before, harnesses and cables are managed on a project level. So coming in here, I can have access to all the harnesses that are defined for this project. Here, I'm going to create a new harness called H7. I do have the ability to assign any manufacturers or metadata information that I want. If I expand this, I could see varying elements that can participate within this harness. There's nothing listed there because I just created this as new. But right here, guys, again, it doesn't get any easier than this when it comes to defining a harness. Real quick, though, I'm going to point out, when it comes to a harness, in this case, we're grouping individual wires and stuff for this harness. These wires carry properties, right? So they're each going to have, a radius, a bend radius, diameter. And then when we group them as a harness, it bundles those all together and, puts any coverings as required. But right here, guys, watch this. Simple right click, select the component, add remove from harness. It doesn't get any easier. Again, now what I'm doing is I'm pushing this metadata easily over to the application who is now handling the management of this harness. I just told it, selected these components. I want to assign you to harness 7. on the, project level, if I access this and expand harness 7, I now see that the wires I just defined and the components that were selected as well are all participants of this given harness. I have several harnesses defined for this project, and we'll look at, getting these routed out. So we're gonna, get ready, jump over to our mechanical environment and take a look at, some of the routing and get into, some further discussion. So coming back in here, guys, nothing new. We already looked at this in the context before, but several connectors, several pieces of equipment, and smaller boards inside of this chassis. Now, mechanical, as I said, started with this workflow. So he's already placed his components. Given the fact that he has access to my project, you can see over there, those drawings are in red. That indicates electrical is working on those live, so he's getting real-time feedback. But we got our model tree over here, which is typical for mechanical. But what is new is access to this electrical components tree. So in here, what I'm seeing on the left-hand side is all the components that were defined within this project. And I have a couple of options when it comes to, either placing these or associating these. Again, I'm just going to show you that this is the manufacturer's information that we saw from electrical inside of that SQL database. So that same metadata has pushed through over here. And so right here, since mechanical's already placed this guy, I simply have to come over and hit associate. He has the option to insert or associate. Here, I quickly am just going to associate it to something mechanical's already had placed. So upon doing so, a few things are happening. Once I made that association, the metadata that came from, the component and the connectivity as defined in the schematic got pushed over to that component. The manufacturer's part had specified terminal connections, and the component has connection points. And so once we make that association, those two are tied together, and the software can understand where each wire needs to terminate. So I'm doing the same here, just with another connector to show the process. If mechanical has it in, it's a simple right click, or he can hit insert, which is driven by the database as well, and we'll place that. Again, you can see that I do have the remainder of, said connectors all associated. Once that association is made, again, all that metadata is being passed over. Here on the electrical tab, because we have the integrated environment, I have tools or access to a lot of electrical information. Notice that, in some of these connectors and models, that in the front of their model name, they also consumed the component tag. And I think that's great when it comes to documenting. Now, real quick, before I route this, I want you to know that I did define a generic path that these will find. It's not a detailed path, it's just a generic route that I want the wires to follow. Then based off of their defined wire properties, they will follow as such. So again, guys, we have a lot of ability to interact with varying commands. In this case, I'm going to go ahead and route some harnesses, just so we can take a look at that. In here, you can, as I stated before, I had several harnesses that I'd predefined within this project. So I'm just going to select a few of these. These are, again, directly being extracted from my project inside of electrical. There's some settings we can go through at another time, but I'm going to go ahead and let this guy run. It's resolving the assembly real quick that was in lightweight mode, and now what it's going through, reading that harness data. It's looking at wire, cable information, diameter, connection information, and it's following that defined path. So as you look at this dialog box as it's going through, you can see the importation of to and from information. Right now, it's focusing on harness 5. Any wires and things that were created within that are getting updated links. So a lot of calculations, and information is happening. But again, the key point, it's all driven from my schematic. If I didn't have the information defined correctly there, I can guarantee it's not going to come over correctly here. And, it's, again, if you use a lot of the library-driven information, it can certainly assist with this. The manufacturer's information becomes a single source of truth. So when I utilize it from there, I know I get the information. So I can see I had, those particular harnesses routed. I got a clearly got an interference, but, you know, routing that in mechanical allowed me to see that. I can address that easily at another time. But let's take a look at one of these routed harnesses. So I can quickly, you know, open this guy up, guys, and get some ability to see that. I also have the ability, you know, here in a right-click menu, because we are dealing with harnesses, with the ability to flatten these in various formats. There's a lot of selections that you can do. Here in this case, I'm just doing a quick manufacturers. Now, you know, what is nice about our layout environment, you know, is we can easily make tweaks to that as we get in there. Now, I cut it short there on purpose because we have a whole nother section coming up that focuses on the drawing and documentation. But a quick recap, you know, when it comes to the schematic environment and what we see defining on the 2D side, it's really a familiar workflow. You know, we understand that we got to place symbols and connect wires, but here, you know, we're dealing with an intelligent library-driven system, you know, again, which is going to increase speed. You know, the library being that single source of truth, you know, it just, and accessing that and letting the software do the hard work is really, you know, where it's at. And reduced auditing, you know, good in, good out. Once that library is, you know, doing what it needs to do, you can have confidence that everything coming out downstream is appropriate. Because, again, of this high level of metadata that we're now able to maintain behind the scenes with the SQL database, it allows us, as which you'll see in this next section, to create improved deliverables. It comes down to this, guys: more engineering, less manual work. Also, once we're in 3D, guys, obviously you saw, you know, what I'm able to get wire length information for both wire cable harness. This will help reduce any errors, waste, etc. As you saw visually, I can rapidly detect interferences and make adjustments on the fly, optimize our packaging for space, get mass properties, simulation fidelity, continued when thermal, structural. So there's a lot of benefits, you know, to go into 3D, obviously, especially when you're an intelligent driven application. So with that, guys, I want to move in to, you know, getting into the documentation side. Now I'm focusing on, you know, a type of document called an interconnect document. But, you know, the concept, again, is, you know, the ability to extract the metadata that we produce in the schematic, that high level of detail, and then what additional information can we get because we did that work in the schematic and because we're working in an intelligent database-driven tool. Now, when it comes to interconnects specifically, you know, they're represented in the magnitude of manners, but they have, you know, one idea in mind, right? Is we want to understand how all of these various cables and harnesses and wires that might be on a system all come together in a singleized place where production can easily, you know, make their connections and understand. And so, you know, again, multiple standards that, you know, people face. Coming to an intelligent tool such as ours allows us to standardize this and, again, really produce high-level documentation. Now, a lot of what we interact with, you know, when creating detailed documentation, a lot of that critical metadata revolves around this. You know, we need to be able to identify component identifiers, right? We got to know people, what connectors they're working with. So that's important. We need to know that it's accurate. And if we're also, you know, trying to articulate part numbers, you know, we need that. And I don't want to have to manually enter the part number in one place and then manually enter it here. It gives me an opportunity to fat finger that. Also, cable and harness names. It all comes down to understanding what you're doing. You know, displays of the physical connections is important too. Actually seeing the connector and where it goes in to its given slot, so there's no confusion. Pin data, you know, extremely important information, you know, that needs to be maintained, and we need to ensure that it's accurate. Again, you know, our deliverables are what's important to us. And being able to get a high level of metadata out there is important not only for internally for your company, but also for your customers. And having to maintain the metadata we're looking at on the screen manually, you know, it's tough. And as we've seen up to this point, you know, the schematic, a lot of this information is defined, right? It's the system understands, the database knows those connections. It knows these component identifiers and part numbers. So when we get into our application and creating this documentation, we make it really easy to extract this information out. Okay, so, nothing new here, kind of a little more complete version of the assembly we were working on before, but again, just, setting the stage, involved, with that same project that we have. And again, I've gone through, the time of obviously doing our associations and, the routing of all of these. I do want to point out, though, again, it is when we made that association between, the highlighted mechanical model, here I'll zoom in on this guy, but, this guy right here, once I associated that with that J1, again, that is where that passing of that metadata comes from. So the software can take that component, understand where each one of those wires need to terminate based upon the terminals as defined in the manufacturer and as the connections defined in the schematic. And so again, this is all just kind of bringing it together so we can tell the story of how this information, is coming out. So we got, the connection, the wire data, all being driven by the application being fully understood. And again, the benefit, what we're going to see in this when we get looking at the documentation, is how easily we can take use of that metadata, of these properties that already reside in the database, because we've created and worked with our schematics. So, that's what we're going to get into as we start to take a further look at getting this documentation generated for this particular thing. So, I do have this put into, a little closer completed state, but I think I only routed 2 additional Ethernet cables for this particular example. But you see, we got, our harness connections, multiple boards, got all of the components and varying harnesses and cables as defined before. We'll just open up this guy, a little different look than the one that I opened before. But again, this is just seeing him as he was physically routed, right? I mean, I guess there could be some benefit to it, but we need to produce this guy and manufacture. So really quickly, guys, as I said before, we can create flattened routes of these guys easily and make those changes. But I'm going to show this kind of continue on the story here, so I'm just going to cancel this guy out. All right, so again, what I'm talking about and what I want to demonstrate is high level of documentation and being able to take what we've defined, these routes, the schematic, and then from there produce what's important, right? What our customers need and what production and manufacturing needs. So what I'm going to do is I'm jumping over here to a drawing. Now I have this drawing most of the way complete. Obviously, it'd probably take me the hour if I was going to do that live. But, I got this drawing set that I've created. It is part of this project. It is managed within this, within this environment. The information that we're going to see displayed is becoming either from the mechanical side or being driven from the mechanical environment. So I was interacting with this model for a moment. So right now, what it's kind of doing as we take a small break here was updating these views in the back. Again, just because actually I'm going to hit the rebuild to get rid of those guys here, just to ensure, again, if anything changed in that model, right, we would want these views to update. So here again, we're starting to see some of the power of this integrated environment. Once we're in SolidWorks, I don't know how many of you guys are mechanical or have mechanical exposure, but SolidWorks is an extremely powerful tool, especially in the documentation phase. The ability to create views, the associativity between the models and the views, etc. So I've started here on a high level, sheet 1, and I'm going to further document in detail this particular chassis out. But again, the concept behind what I'm trying to show is produce a document that will help not only, create individual cable harness assemblies, but also articulate interconnect information within this. So, we got nice views in here, of this particular project and what we want to work. But the focus here is the metadata and the information that I didn't have to do any extra work to create. Well, I guess, yes, I had to do some work, but not a lot. I had to click a few buttons. But again, we see all the views, again, fully detailed from that model, fully associative. Here, I've just used the detail view to break this out with a further detail of more of the area of which we'll be working. But one thing, take note of this. This is an electrical bomb. This was generated automatically when I started creating my drawings, and you'll see some of this as I go through some of this documentation. But again, that's software driven. I don't have to maintain that. When I create a drawing, it asked me if I want to include an electrical bomb, and I said yes, and there it is. As I update and modify this, that information can update as well. Now, here we're kind of getting into a further detailed documentation view. On this particular sheet, I can get a visualization of all the connections for the overall system. We'll further look at defining and articulating these harnesses or cables individually, but this document, this particular sheet, again, the full focus of this is to articulate that interconnect information. Because I had each one of those harnesses or cables routed as a separate subassembly, I was able to bring them in. So I am using varying SOLIDWORKS view capabilities to display the information in a manner that I want. Bringing the component views in, placing the harness, views where they would go to help articulate that. Again, I'm getting all of these system-driven tables. Everything that you're looking at as far as a table, a call out, a balloon, driven by the application. The metadata contained within them, driven by the system. Comes from schematic information, right? So I'm defining these connectors. I've defined, all this wire to and from information. But when it comes here, it's like putting a puzzle together, right? I have the metadata. I'm just selecting the views, where I want to place a view, etc. And as I get further into this presentation here, guys, you're going to see how easily I have access to this data. But, besides, again, like I said, kind of putting puzzle pieces together and laying it out the way that I want, it took no more labor on me to create, such a layout besides just placing the tables where I wanted, placing the views where I wanted, etc. But again, keep in mind the associativity here, guys, that everything in the SOLIDWORKS environment is tied back to a model. So if the model changes, then this view changes. And if I wanted to update a route, I can change properties such as wire sizing, cable manufacturers, and the schematic side, reroute, get that information put back in here, and, the views can update. Depending on the scope of that change, can obviously impact how much change has to be done. But again, the software manages that for you guys, all those relationships, etc. None of the data in any of these fields or any of these tables required any extra, information off of me. But again, we're able to produce high-level documentation in this integrated system. Again, and the whole concept is to get more with doing less, right, guys? I'm sure, we're trying to produce this information, and unless you're in a database-driven application, a lot of this is manual. So you're populating, this data, the color information, the connection pin data, all manual. And again, as we're all aware, we're all human. It's easy to make a mistake. There's nothing better than removing that risk or mitigating that risk and allowing the application to manage that for you. So again, this is, showing what I was able to create here as far as an interconnect drawing. Again, using a combination of views and table and metadata from both the mechanical and the electrical environments. So here on this, let's see. Yeah, let's switch down here and go take a look at some of these further detailed, separate cable and harness assemblies. Yeah. Let's see this guy. Okay, so here I've gone ahead and opened up another drawing. Now this one is specific to a cable in this project. Again, I just have varying views. I just threw things out here just to show the flexibility of it. But here with this center detailed view that's shaded, I can get some nice color, understand its orientations. Here I was easily able to create a flattened route, for this and bring that flattened route into this drawing. So again, in an associative environment, I got detailed connector views driven by the models of those connectors, etc. Again, the benefits of a full associative environment. Here you're seeing my connection labels, again, calling out, easily articulate that this is related to X2. You can see the BOM information. The same holds true for this drawing. Every call out automated by the system. You might notice how in the detail views, you're seeing some red. I was able to play with SOLIDWORKS layers within each one of these views, so I could highlight this particular harness or cable assembly in here, whatever it may be in this particular red quarter. So again, once we get into this environment, there's just so much power, that we can do to help improve our documentation. And by improving our documentation, we improve production assembly time, troubleshooting time, our customers' experience. But we're not only getting that benefit, guys, we get the benefit of an associative environment that manages the change for you. That's intelligent, database driven. So we'll continue, to look at this guy. And again, I'm going to come in here and make some changes. But let's jump over to another sheet. This is a more demonstration of a harness. We'll let this guy generate here and get opened up. All right, so again, this is just a different representation, combining the power of, the SOLIDWORKS mechanical drawing environment with the metadata of the integrated electrical environment. So I'm not doing anything that I haven't articulated before we've looked at here. Again, it's just a different drawing type and a different way to look at it, but each connector, has connection table information with detailed wire data based off of that information, pin to and from. All that information that we looked at on that slide that is critical is on these sheets. And furthermore, it's system driven. I can't say that enough, but that's what's important, and that's where the value is at when we start working and creating this level of detailed documentation. So let's take a look at a couple more things here. I'm going to open up another drawing, and I'm going to come in and do some more of this detailing that I've been showing. So let me just remove some items because I'm going to come in and show you how the software does it. I'll just do a slight cleanup here. Move a balloon, tags. All right. So again, this is mechanical. We'll say from here, I pulled out some mechanical views, but now I want to get, that electrical metadata over here. When you're creating a drawing, you have the ability to do it, but because, the software understands, that metadata, notice as I click on these elements under this note that I'm getting ready to apply, one of the properties that, you can link it to, I'm going to drop this down, is going to be file name, which in this case is my harness, or cable name, whatever that need to be. Now again, automated, driven by the system. That name change, that tag change is there. So again, requires no work of me besides just clicking the note command. Same you'll see here for ballooning. We can automate this at the creation of some of these drawings, or if you need to add after the fact there, I just selected the property I wanted to map to, which is the component reference. Notice as I pull these guys over, all of those tags are being extracted from the component, when the component is also tied to the electrical representation, which is driving the tag. So again, you can kind of see how that metadata was put there. Now I'm going to show you, getting, extracting connection information. Again, all of this data resides within these views, which contain the models, etc. So on this guy, I can simply right click. Because this is tied to electrical, down here in the lower section, I have an area called electrical tables. I'm interested in generating some connector tables. So you can also generate a cut list and a BOM. In this case, I only want my connector tables. So it's wanting me to select the connectors. I could have selected all of the connectors in this view, but just showing you the flexibility. If you had a lot of connectors, it's going to automate that process. Again, it is tying that information to the component which it was referenced off of. So in this case, we reference X1. We get all of the connection data driven there for X1, all that pin information. The table was located, in correlation to, the location of its said connector. So again, as you witnessed, in this example, once the schematics are created and we're feeding the metadata into mechanical, from there, with all the connection and property information of the wires, cables, and harnesses defined, we can get the routes. The routes give us the links and help us catch interference and optimize the packaging. But what we witnessed here is the power of documentation, how we can extend the value of what we're already doing and capture all the critical metadata that we need, our customers need, and our production needs, and easily articulate that into high quality professional documentation. So in closing, guys, SolidWorks Electrical allows for connected systems, electrical, mechanical, connected teams as well. The collaboration that can happen internal to the application, understanding who's engaging with what, is great. The single source of truth, guys. Standardization for organizations is a struggle. And so having a single source of truth is definitely highly beneficial. Intelligent electrical design. Let's remove a lot of the manual error-prone efforts. Let's add that centralized database, and let's get this done quickly, and let's get it done right. And then most importantly, we can produce improved documentation that allow us to save production costs, reduce waste, and again, increase troubleshooting speed and our customer satisfaction with the overall delivered package. So guys, harnessing is a topic that we could spend days on. It's an exciting environment. We have a lot of powerful tools to interact with it. So I hope you continue to join us for future webinars, guys, where we will continue to dive into topics on harnessing or all things electrical. So with that, guys, I did exceptionally well with my timing. I was all over the place prior to this, but we do got about 13 or 12 minutes here of Q&A. So JP, we'll take any easy questions you got. No, I'm just kidding.
So one question that just came up right at the end here real quick while I was trying to type it, but I figured, hey, why not you just answering it here is it easy to add heat shrink, labels, things like that to a harness? And I could answer that real quick for you. Yes. So what you can do is once you route your harness, after you route it, it becomes a feature in your feature tree. And at that point, you can edit that harness. And what I've done is in my toolbox or through my routing library manager, I've created additional pieces of heat shrink or a label or like the little zip tie, if depending on what industry you're in, little metal piece that goes on there for the tag, right? You can snap those into place. And once you're inside of that subassembly for that harness, now you can go in and turn that into a drawing, and all that information is a part of that. All right, so that was one question. Another question here was, let me see if I can find it. What is a cut list, Thomas? Go ahead. That's an easy one for you.
Okay, yeah. A cut list is essentially, it's going to be the wire information, of where it's going to, where it's coming from, length information for that segment. So we know at each segment of that, what, to, from, and length information produces it into a table that articulates the same.
Yeah, wire run list, to, from wire list, they're all kind of go hand in hand. Here's a question for you, Thomas. Can you explain the quotes here, separate 3D route option a little further? I guess maybe the difference between the 3D route and the premium route.
Here, I think the easiest way I can articulate this, guys, is, so say I added 3 cables to my project. I did not select that route as separate assembly. I go into mechanical and I select route cables, and I just keep it as all cables. It routes 3 cables. You can see them as individual, little routes, but in the what is it called? The component tree, they're represented by one subassembly. So you have one subassembly that highlights all three of those cables. Now that might not work if you're going to lay it out, would it? Because you try to go to that subassembly, you open it up and you got three. You only wanted to lay out one. So if I use that checkbox that I demonstrated or showed and check that for each one of those, then I can route all cables, and each cable is a separate subassembly. So I hope I articulated that well. I can show it as needed too, but you can send us a thing if that helped articulate it. If not, just let me know and we can go.
Let's see here. Where does all the metadata for the centralized database come from?
Well, if I understand so it can either come from existing library data that you might already been acting with, but we also ship, with the manufacturer's library out of the box, and then we give our customers access to an electrical content portal, which has hundreds of millions of part numbers in it. You can download manufacturer's content on demand as needed. That's already configured for the application. And so it resides in our SQL database once we get it in there. So do you think that was the question, is where do we get the data?
I would guess so. I mean, right, you have the option of, if you already have another tool that you want to import information in, you can obviously manually create that information. And there was a third one that I was just about to say, and I started reading questions again and I drew a blank. Those are really the two big ones, right? Pulling information in, or the ECP is the other one, right? You can download it from there and pull it in. So.
Exactly. We have a plethora of data available to you, libraries, etc., that can help.
Let's see here. So is there, I think this more in line with the API, and I don't know the back end of one of the other tools, and I won't say the other tool's name, but how easy is it? And have you had any customers, maybe you can answer this, I know a couple, but can you connect other tools, PCB tools, for example, to SOLIDWORKS Electrical, maybe through the API? But
there's definitely some varying methods of integrating data. It depends, on the PCB tool. I know that there's ways they can export certain references that we could there import into our application, reference it as a symbol and add connectors and things to it to represent the connections. That way, when we get to 3D, we can pass that data as well. But also, depending on the 3D applications, there's various connectors involved within the 3D world that can help from a PCB world into a mechanical, which then we can connect electrical to. So there's a variety of ways that we can address that. Specifically, if you're looking for more information, I would love to have a discussion and understand your current tool, what applications might be in play. We do have an open API, as JP mentioned. All customers can have access to that. Extremely powerful. As we know, that's what APIs do. So we'll leave it at that for now.
And then how much time we got? We got like a couple more minutes here. One more question here. This is regarding not so much simulation, I would say, but more in regards to like we offer the default, the voltage drop, right? But to go a little further into this, is it possible to create reports that are not just voltage drop, right? I think it would be more in line. Maybe there's some type of RF loss might be would be a good one, I guess, or frequency, any type of additional report. So now my take on this is to try to answer this, and you can back me up on this, is that each cable, each wire type, right, you can customize those to include additional information. So in my case here, my background was DoD, and I did a lot of RF work, and so I customized my wire reports to include things like impedance of a circuit, or 75 ohm versus 50 ohm, things like that for that wire or cable type, right? So you can include that kind of information, and that way when you go to create a report, now you can pull all those different pieces of metadata. Most likely you'll need the spec sheet for every single one of those cables that you want to import into your, or manually type it in, right? Unless it's in the ECP. So that's the one way I would think about doing that kind of stuff. You don't have to add it all at the first time, right? If you have, I see somebody here, I have millions of parts or I have thousands of parts. Are you using all thousands of those parts on your first project? Maybe, probably not though. So you can just slowly import them in. You don't have to have all of them in at one shot. Plus it gives you a chance to kind of like clean up your library and, pick the ones that you really use all the time. So.
Yep. Yeah, and to further back you up on that, JP, one of for those of you on the call, a type of report that we have on our schematic tool, one is called a DRC, or a design rule check, and that's where we perform the calculations such as voltage drop. Now, those are customizable SQL queries. Again, because we're built on powerful SQL, we can do a lot of things as far as creating formulas driven, within those custom SQL queries to help produce varying levels of calculation. Comes down to what JP said, the metadata within the database, it resides there. We just, tell it what fields we want to interact with, what calculations need to be ran, and then we can typically get a report off of that.
All right, let me see. Let's take one more. See if I can find a good one here.
Better be the suspense.
There's a lot of them. I'm trying to find some good ones here. I got a lot of.
You're helping me out. You're finding the easy ones. Keep them coming.
Is there a DRC for wire aug to pin crimp size?
Yes. We can build it in. Yeah, we can build in a DRC. So one of the out-of-the-box ones that we have is, to help appropriate, ensuring that the appropriate wire size is terminating on the appropriate terminal that can handle or accept that. So we can define on terminal various connections and types, minimum and maximum wire gauge. And we have DRCs that can, look within the range of minimum and maximum and then flag it if it is outside of that range. Thanks for being with us, and look forward to talking to you guys more.
Thanks, everybody. Stay safe.